In this video, we will review maps within the Java programming language. You should already have had exposure to Java maps in the VTC course Java 7 Language Basics, so we will quickly be reviewing it in more depth. In Java, the map interface defines the basic support for storing key value pairs and collections, where each key can map to one value. While map is part of the framework, it does not extend from the collection interface. Instead, it is the root of its own hierarchy. There are four concrete implementations of the map interface: hash map, weak hash map, tree map, and the historical hash table. In this lesson, I'm going to show you how to implement the equals and hash code method. This is an area where developers sometimes can make mistakes. First, let's take a look at our code. Here we have a user object, our class which models a user in a system. The ID represents a unique value. In other words, each user must have a unique ID. We have our name field for the user's system name, and we also have a field to capture the user's email. We have a standard constructor using settings in our field values. Then we have getters and setters to retrieve and set values for our fields. Now we're going to override the equals method, and here are a few notes on overriding equals. Equals should usually compare state, not identity. This is particularly true for data-centric classes, which map to database records. Hash code and equals are closely related. If you override equals, you must override hash code. Hash code must generate equal values for equal objects. Equals and hash code must depend on the same set of significant fields. You must use the same set of fields in both of these methods. You're not required to use all the fields. For example, a calculated field that depends on others should very likely be omitted from equals and hash code. Objects placed in a list, set, or map as either a key or a value should have an appropriate definition of equals. Let's dissect equals. Here, what we're doing is if the object is compared with itself, then we return true. Before you can use the parameters passed to the equals, you must verify that is not null. And if it is, return false. This makes sense since something cannot be equal to nothing. Once you determine that the reference is not null, you need to check to see if one object, this one, is equal to the object passed in, or the other object. Notice that the data type of the other is object. This means that any kind of reference can be passed to your equals method. After determining that the reference passed in is not null and is the same as this, you typically check that all of the instance variables of each object are equal. Here we're checking that ID is equal to ID and name is equal to name. Hash code is a method that we override in our custom classes, and it's mandatory to override if the equals method is overridden. Hash code is also used in hashing base collection classes such as hash table, hash map, and hash set. Hash code is a numeric value. Now, since it's a number, it's always fast to retrieve an object using a number rather than an alphabetic key. Hashcode method is used to get a unique integer for given object. This integer is used for determining the bucket location when this object needs to be stored in some hash table like a data structure. By default, object's hashcode method returns an integer representation of a memory address where the object is stored. Now, taking a prime hash, for example, the number 5 or 7, 17, or 31, the prime number as a hash results in distinct hash code for the distinct object. So that's what we'll call our seed. We're going to take another prime as a multiplier different than the hash, which is good. We'll use number 1. Then We'll compute the hash code for each member and add them into the final hash. Repeat this for all members which participated in the equals. Finally, we return the hash. A step of caution that needs to be taken is that while implementing the hashcode method, the fields that are present in the hashcode should not be the one which could change the state of the object. When do we overwrite and implement our own hashcode? Well, since hashcode is a numeric value, it is used in retrieval of the respective. Now, since it's a number, it's always fast to retrieve an object using a number rather than an alphabetic key. In what scenarios do we override equals in hashcode methods? In any concrete implementation of the map interface, the hashcode method only gets invoked when you use the object as the key. It is not used when the object is concrete implementation of the map interface value. Most of the time, your concrete implementations of the map interface keys are simple strings, so you rarely need to write custom equals in hashcode methods. This helps you check for duplicates objects. We need a custom equals in hashcode method because here our object acts as both key and value. And let's demonstrate this in our code. Here we have a user object, user1, and we have user2. Both user objects are instantiated with the exact same values of an ID of 100, a name of Ted, and then the same kind of email. Now we'll check if our equal method works here by comparing them to each other. We will use a hash map to store our users, and we will add both objects to this hash map, using the object as the key and the value to the hash map. We're going to see what happens when we run our code. Right-click on your source, Run as Java application. First of all, the users equal true. The contents of the hash map prints out both users equaling each other, and the hash map size is 1 even though we placed both objects in the hash map. So even though we added two objects, by implementing our hashcode and equals method, our hash map removes the duplicate keys and values. This concludes our discussion of maps in Java.